Hello, Math Champions. In the previous video, you learned about congruency. Okay, if you have not learned about it, go click on the link on the top right corner of this video. You'll understand congruency. And once you understand congruency, similarity becomes very, very familiar. Okay, now what is similarity? We were talking about shapes which are looking same, but they're not exactly overlapping. What do we talk about? What do we do about those kind of shapes? Okay, here I've kept multiple shapes here. Which of them are looking exactly same, which of them look same but they're not exactly same. Okay, let's take this trapezoid, right? Are they looking same? Both are trapezoids. Are the lengths are same? Everything is same. Are they overlapping? Yes, absolutely overlapping. So that means this is a congruent shapes, right? They're congruent shapes. Now this is a square, this is a square. They're both looking same, but then they're not exactly overlapping. This is not exactly overlapping. Let us keep it this side. Okay, this okay. Now what about this pentagon? This completely odd. This, it's not matching with anything here. So there's nothing congruent also. Nothing. Nowhere it is looking same like any of the other shapes. So let's leave it that. Let's remove that. Okay, now coming to these shapes, okay, now these two, let's say, these two are exactly overlapping, so they are, it comes in the same situation. Now that means these are congruent triangles, right? Congruent triangles. Let me take a similar one, another one. Let me take. Okay, so this completely congruent. They are. These are congruent set. These two are not congruent as of now. Let's see what happens to them. Okay, now this one, is it matching with anything in the shape or any size or anything? No, it's not matching with anything. So let's remove that also. Now look at this and this. This and this, what is happening? They're looking similar. They're looking like this same triangle, but then something about it is not same. What is it? The size is not same. The size is not same, right? Now what are the things that is equal in congruent? If you say this angles are equal, right? The angles are equal. And here the angle also is equal, okay? Let's see. Here also, this angle 60 degree, this is also angle 60 degree. If you measure, you will come to know. And the angle is same here. This is also 90, this is also 90, right? 90, 90, 90, 90. 90, 90, right? This is 60, this is also 60, this is also 60, this is also 60. That means angles are same. That is what makes us think they are same, right? They're looking same, right? Angles are same. Here also angles are same. Angles are same, right? No problem. Here angles are same. Now, along with this, what happens in our congruent shapes is that the sides lengths also, the side length, the length, this length and this length, the lengths are also same. This length and this length is same. This length and this length is same, right? So lengths also are same. Lengths are same. But here, the problem is this length is not equal to this length. It's not equal. So what to do? What to do? Okay. How about the square? The square is the same story. The angles are same, but the length is not same, right? Lengths are not same. But is there any connection between those lengths? Okay, let's take a scale and try to try to get, let's see what to do about the lengths. Okay, length here is say 1 centimeter. Okay, 1 centimeter. This is okay. The length here is 3 centimeter. Okay, and if I am okay measuring the next one, right? I'm going to measure the next one. Length here is 1 centimeter. Length here is 3 centimeter. Look at this, right? Approximately, right? I'm just moving this 3 centimeter. Okay, so and what is happening here is if this is 1 centimeter, this is 3 centimeter. This is 3 centimeter. If this is 1 centimeter, this is 3 centimeter. And let's see the other side also. Let's see the other side also. Second. Mm. The other side also we are measuring and we are seeing that this length is also 1 centimeter. This length is also 3 centimeter. That means I'm not saying all the three should be same, but the connection between them is that this is 1 and this is 3. This is 1 and this is 3. That means, okay, let's take some other shapes. Let me take this triangle, okay, this triangle, and let me have another looking, these are congruent triangles. What am I going to do is actually, okay, so they are like looking same. What do you notice here is that, let's take this scale, and how much is the measure of this? Let's see. How much is the side measure? This is 2.8. Okay. 2.8 this side. Okay. Let's take, let's take this one. This is 1.4. This is 1.4. Now, are we seeing any connection here? 1.4 and 2.8? Yes, this 1.4 times 2 is 2.8. That means there's some connection of times 2. Let's see whether there's a similar connection with the other sides as well, right? So let's measure this. This is point 0.8 or 9, 0.8 or 9. This one is 1.8, 1.9, right? Let's measure again. Almost zero point 0.9. This is 1.8. What is happening here? This is 0.9 centimeter. This is 1.8. Is there a connection between these two? Yes, absolutely. This is times 2 of this, isn't it? That means to say what? That means when the shapes are not congruent, they are called similar when the sides are proportional. Sides are proportional. They're not equal. They are proportional. That means if one thing is 1 centimeter and the next shape has the same, 2 centimeter, it becomes then this 0.9 means the other side, the corresponding side in the similar triangle will be 2 times of it. That means to say, if I'm having a triangle ABC here, and if I'm having a triangle DEF here, what can I say is, if they are similar, if triangle ABC is similar to triangle DEF. Means similar means 3 lines, okay? If they are equal, that means AB of one triangle divided by DE, the corresponding side, which is matching side, the fraction, right? The factor, the scale factor will be same. Like for example, here it was 1/3, right? AB was 1 centimeter, DE was 3 centimeter. That will be same as AC over DF. That will be same as BC over EF. That means they are all proportional. Their all sides are proportional. So for similarity, two things need to be there. Two things. What is that one thing is angles. All angles are same. All angles are same. And sides are proportional. Sides proportional. Okay, sides proportional. So let me write it very clearly again here for your understanding sake. Delete this. Okay. So in triangles, similarity means angles need to be same. Now, is it required all 3 angles need to be same? Angles are equal. Is it a necessary thing? No. Why? Because even if we know 2 angles, the third angle will be same. So 2 angles or 3 angles need to be equal, and the sides need to be proportional. Sides are proportional. Means if one is increasing by one factor, other one is also increasing by the same factor, isn't it? That is when they are similar. They are not overlapping like congruent, but they're looking similar but increased in size. When they increase in size, the angle does not change. Only the side lengths are changing. And when they're increasing in size, also they're exactly increasing same way. That means not that only one side is increasing, other side is not increasing. No, no. one side is increasing from 1 centimeter to 2 centimeter, means other side also is increasing from 2 centimeter to 4 centimeter. That means that much amount, that many times only it is increasing, other things also. So I hope you're understanding this is the meaning of similarity, right? What is the difference between the similarity and congruency also? I hope you've understood. If you've not understood, start the video from beginning and learn. And as I always say, go ahead and practice so that you can learn to identify similar shapes, congruent shapes. If it is similar or not, how to check. We have given you the conditions. Use those conditions and check whether they are similar shapes or not. Okay, go ahead, my champions. Keep practicing, keep learning, and mastering the concepts one by one. I'll see you in the next video with yet more concepts of mathematics. Until then, see you. Bye bye.